All right, physics reaction video number 84. It's been a while since I've done this. Took the summer off basically. Got a new job, but still at the same place, just different place in the structure. But still love doing this. So we're going to go did a search for I think physics lecture, but limited it to this week, and I found this this lecture here.
Date at the top of the lecture number. Today's lecture is going to be all about graphs of motion.
Cool.
Okay, so sketch for yourself a displacement versus time graph. Displacement is sometimes called position. We can use both. But it's a XY graph, and something that's important to note is that time is always going to be on the x-axis.
Something that always strikes me is that we always use lowercase t for time, when we're doing formulas and stuff. And so then this capital T, for me as a student, always struck me as weird. And so I don't know why. This never bothered me because this ends up usually being X. But when we call it X, we would never put a capital X over here. So there's something that catches my eye every single time about the capital T in time, given that it's almost always shows up as a lowercase t in any formulas we might use. So anyways, just something freaky about me. I liked what he said. Okay, so let's sketch ourselves a graph. I think he meant sketch yourself a nice set of axes. And he said, yeah, it's lecture 5. They've already had a little bit of work together, and so the notion that these two need to be at right angles, I'm sure, has sort of been drilled in now. The fact that these need to be evenly spaced has probably been drilled in now. He's already given them, an example of the range to be worried about, right? So this is not so two units this way is not the same as 2 units this way, but of course they have completely different units, so it doesn't make any sense. These are meters and these are seconds, and so I think already a good setup. I love it.
For all of the graphs, sometimes this will be displacement position, but we'll also see this with velocity or acceleration. But time is always on the x-axis.
So confusing.
And position here is just one dimension of movement. So 1d of movement.
Real quick on this statement right here, they'll go years without this ever breaking, and then all of a sudden you take relativity, and for whatever reason they decide to sometimes put time on the y-axis. So yeah, it's weird.
We want to try to simplify movement here. We know objects can move in 3 dimensions, but we're just going to focus on those dimensions separately. This might be just left or right movement. It might be just up or down movement.
Love that. Because the graph makes it seem like it's up or down. Cool.
So let's draw a couple different graphs. We can try to do this on the same graph. But how are we going to interpret different shapes of these graphs? So if we ever see just a horizontal line.
So I'm going to pause for a second and talk about functions, right? So the students sometimes in a math class may have learned about functions a little bit, and there's some things that these graphs can't do, so they can't sort of turn around on each other, right? And having time on the x-axis really helps drive that home, because if you had something that went like this, and you say, wait a minute, what's happening at time equals 4? Well, wait a minute, it's like it went back in time. And so students, I think that having time on the x-axis helps the notion that these have to be functions, right? They need to be single valued at every time.
It doesn't look super horizontal, but let's say it's flat.
Doesn't look super horizontal.
And horizontal, this is an object that is just standing still. So
Cool.
It's not moving at all.
Cool.
So maybe I've got a tennis ball. I just set the tennis ball down 1.5 meters away from myself, and then I don't move it. I check 2 seconds later, it's still 1.5 meters away. I check another 2 seconds later, it's still 1.5 meters away.
I like that.
It's still 1.5 meters away. So it's never moving, but time is moving forward, so that's why we see this arrow moving to the right. But it's not going up or down because the position away from me stays flat at 1.5 meters. Another way this could look is it could have a positive slope. So we could have a line that looks something like this. So this is moving away. All right, so I said
So it's interesting. So words like away and towards sort of personalize it, right? To away or towards you, or in this case, the origin, right? So, students like every once in a while could choose an axis that's wonky, so that the origin is far away from them, and they're sitting at meter marker 3 or something. And so I think that this is going to have to end up being moving away from the origin, but a lot of times, especially the way he talked about this tennis ball here being 1.5 meters away from me, that's going to work. Put yourself at the origin. And then using phrases like this is pretty cool.
set a tennis ball down 0.5 meters away from myself, and I give it a little push. I check 2 seconds later. It's a little bit further away. Check 2 seconds later. Now it's a full meter away. 2 seconds later, that's like about 1.5 meters away. And so it's a flat line with a positive slope. It's right that this has a positive slope. That means that the object is moving away from the observer. All right. Now, we could have another positive slope, but much steeper. So how is this different from this example? So let's just say steeper means faster.
Cool.
Steeper means faster.
Love it.
So the steeper the line, the faster it's moving away from you. And one last option here, at least for this slide, is we could have an object that starts far away from us and then starts moving towards us.
Cool.
So this is moving towards the observer. So moving towards.
Oh, I like this.
All right, so now what we're going to do if that line is curved. We can have lots of different curves possible, but we might have a curve that looks like this, or a curve that looks like this.
Oh.
These types of curves.
Oh, that was super cool to go below the axis. Great timing to do this, because really trying to understand where the borders and boundaries are to this. That was super cool. I thought that the second one he was going to draw on a second axis, but he's starting to draw a lot on the very same axis. And so I think that he's really starting to build the sophistication for his students about how these graphs can tell stories. Very cool.
Are getting steeper and steeper. Notice this one I had go into the negatives. Position, displacement can definitely be negative. That just means that there's a positive direction and this object is maybe moved behind the observer.
Very cool.
All right, so getting steeper, both of these, means the object is accelerating.
So let's compare and contrast the different ways he could have done that, right? So he could have had this pre-typed or pre-written and then suddenly displayed it. He could have just said it, or he could talk at the same speed that he writes, which is what he did. But that is a definite clue for his students, like, you should be writing this down. So I think that slow talking that's the same speed as your handwriting it eventually becomes a clue for your students, like, oh, all right, well, he's taking the time, so I will too.
We're going to spend many days on acceleration, but just know for now that getting steeper means the object is accelerating. There's another option where it starts steep and gets flatter and flatter.
Ooh, is he going to say deceleration?
Like this or like this.
Or is he going to say that's also accelerating?
And for that one, we're going to write that getting flatter means slowing down. It's still moving, but with a slower and slower velocity. And we'll learn that slowing down is just a different type of acceleration. So all curved lines
cool.
are some type of acceleration.
All right, I think I'm going to pause right there. I just really wanted to come and look at a straightforward one here early in the term, I'm guessing. Really, really liked some of the scaffolding that he's building into this. I liked the interactivity. He didn't have these graphs pre-made, although he clearly had a plan. I don't know. I just thought the scaffolding in this was really, really great, and I think that the students are developing a sophistication of understanding these things. So, all right. Well, that's it for me today, you guys. All right. Have a great day, and remember, physics teachers are awesome.